In this lecture here, we want to begin our study of rational expressions. And just like the previous few lectures, what I'm going to do is I'm going to break up these topics into multiple lecture videos for you to watch. So when we talk about rational expressions, these are the main topics we're going to cover over the coming lectures. We want to specify numbers that can be excluded from the domain of a rational expression. So I'll talk about the domain in this lecture. We'll talk about how you simplify rational expressions. Then we'll talk about operations on rational expressions. So we'll talk about how you multiply and divide. That's pretty easy. And then we'll also talk about how you add and subtract rational expressions. And it can be easy when the rational expressions have the same denominator, and a little bit more difficult when they don't. So those problems will be a little bit more complicated. So in this lecture here, what I'm going to talk about is domain and simplifying rational expressions. Okay, so a rational expression is the quotient of two polynomials. So let me give you some examples of rational expressions. Okay, so for example, so it's the quotient, so it's going to be division of two polynomials. So it can be something as simple as this. It can be something as simple as 1 over x squared. All right, or it can be something like this. X squared minus 3x plus 7 over x squared minus 81. Okay, it can be anything like this. Okay, as long as it's the quotient of two polynomials. Okay, so the set of real numbers for which an algebraic expression is defined is the domain of the expression. Okay. So think about this. When you have a division here, when is it undefined? So domain is all values for which the expression is defined. Okay, so going here, because rational expressions indicate division and division by 0 is undefined, we must exclude numbers from rational expressions that make the denominator 0. So the domain here cannot include values of x for which the denominator would be 0 or would equal 0. All right, so I want to show you now how you can find the domain of a rational expression. All right, so let's find all the numbers that must be excluded from the domain of this rational expression. Okay, so when you want to find the domain here, you're going to look at the denominator. So I'm going to look at this x squared minus 5x minus 14. Okay, you don't have to worry about the 7x here. So what you want to do, excuse me, is you want to figure out what values of x will make this expression equal 0. So the easiest thing to do here is to factor the expression. Right? So, we learned how to factor trinomials here in a previous lecture. So you're looking for two numbers that sum to minus 5 and multiply to minus 14. So those two numbers would be minus 7 and 2. So what that means is this can be factored as x minus 7 times x plus 2. Now figure out, so you want to figure out when this is equal to 0. So then what you're going to do is set equal to 0 and solve. So you have x minus 7 times x plus 2 is equal to 0. So either by the 0 multiplication property, either x minus 7 must be equal to 0 or x plus 2 must be equal to 0. So what that means is the values of x is equal to 7 or x is equal to negative 2 would make this expression undefined. So they cannot be in the domain. So what this means here, okay, what you cannot have then is you cannot have for this expression x cannot be equal to negative, or it cannot be equal to 7, or x cannot be equal to negative 2. All right, so those are the values that would make this expression undefined. So what's going on here then is the domain is all real numbers except for -2 and 7. Okay? Let's try another one. So let's find the domain of this. Let's look at 1 over x squared minus 1. All right. So we'll look here. Again, you're going to factor the denominator. So this is the difference of two squares. So this is going to factor as x plus 1 times x minus 1. So then look, you're just going to set the denominator equal to 0. And then you're going to solve. So you're going to look at x plus 1 times x minus 1 is, when do I get a divide by 0? When does it equal 0? Well, either x plus 1 has to be equal to 0, or x minus 1 has to be equal to 0. Well, you subtract the 1 over here, you get x is equal to minus 1, or add the 1 over here, x is equal to positive 1. So this expression, okay, you can plug in any numbers except x cannot equal -1, okay, and x can also not equal 1, right? So it's all real numbers except for -1 and 1. That would be the domain of this function. All right. Now let's just talk real quickly about how you simplify a rational expression. So a rational expression is simplified, okay, if the numerator and denominator have no common factors other than 1 or -1. So for example, if you have just the fraction 8 over 10, right? Like you're used to simplifying this. 8 is 2 times 4, 10 is 2 times 5, and you notice that the 2's cancel out and it simplifies to 4/5. That's kind of what is going to go on with these simplifying rational expressions. Okay, so what you're going to do is the following procedure can be used to simplify these rational expressions. You're going to factor the numerator and denominator completely, right? And then what you're going to do is you're going to divide the numerator and denominator by any common factors. I.e., really what you're going to do is you're going to cancel out common factors, like I did over here. They cancel out in the numerator and denominator. So the key here is factoring, right? Like you see, even when we went to go find the domain, the key is factoring here. So when you want to simplify these rational expressions, the key is also factoring. All right, so let's try this one. So I want to simplify x squared minus 1 divided by x squared plus 2x plus 1. Okay, so the first thing you're going to do is you're going to factor. Well, this we saw is the difference of two squares, so this is going to be x plus 1 times x minus 1. Okay, so then what two numbers multiply to 1 and sum to 2? Well, that's 1 and 1. So this is going to factor as x plus 1 times x plus 1. Well, look here, okay? What's going to cancel out here? Did you notice how they both have an x plus 1? So cancel out, cancel out. So this still just simplifies to x minus 1 over x plus 1. And just be sure to note the domain. So when you want to find the domain, you find the domain of the unsimplified version. So it's still x can just not equal -1 here. All right, let's do a another one here. Okay, just so you can see. Let's simplify this. Let's look at x squared minus 36 all over x squared plus 8x plus 12. All right, so the first thing you do is you're going to factor, right? So this looks like the difference of two squares because 36 is 6 squared. So this will factor into x plus 6 over x minus 6 divided by, okay, what two numbers multiply to 12 and sum to 8? Well, that would be 6 and 2. So this is going to factor into x plus 6 and x plus 2. Okay, so look, the domain here. I hope you can see right here that the x plus 6's are going to cancel, but look, you just look at the denominator here, right? You can see immediately that x cannot be equal to -6 or x cannot be equal to negative 2, right? Just by looking at it. So now you're going to cancel it out. And you're going to be left with x minus 6 over x plus 2, but x cannot be equal to negative 2, and x cannot be equal to negative 6. So when you go to find the domain of this, okay, find the domain of the unsimplified version, okay? So that's it. So the key is factoring here, all right, and then and then just canceling out common factors. So I'll just do another quick one right here. Let's simplify. Let's look at x squared plus 7x plus 10 divided by x squared plus 8x plus 15. Okay, so what two numbers multiply to 10 sum to 7? That's 5 and 2. So this becomes x plus 5 times x plus 2. What two numbers multiply to 15 sum to 8? Well, that's 5 and 3. So just looking down here at the domain here, I'm just going to put D. X cannot be equal to negative 5, and x cannot be equal to negative 3. Because if you were to plug either of those values in here, you get a divide by 0. But then you could just cancel out these common factors here, and you're left with x plus 2 over x plus 3. All right, so what I'll do next is I'll follow up this lecture here when we start talking about operations on rational expressions.